All right, it's time to start chapter 12 here. We've got 12.1 and 12.2 at the same time. Woo-hoo-hoo. You guys can handle it. Trust me. All right, we like to cover both these sections at the same time, prisms and pyramids, because they're kind of related here. They're all types of polyhedra. Okay, a polyhedra is just a flat-sided figure. Okay, now a prism is one of those types. It's made of a bunch of flat sides. Primarily rectangles, and then something else. So let's take a look here. A triangular prism has triangle bases, the wonderful shaded parts, and then the other faces are made of rectangles. A rectangular prism, two rectangular bases, everything else wrapped around is rectangles. Really, you could pick any pair of rectangles as long as they are across from each other. And in fact, the bases in a prism are parallel. Bases are parallel in a prism. That's a fun fact there. Maybe jot that down. We can continue on here. We can go to pentagonal prisms, hexagonal prisms, so on and so forth. The base can change shape, but the lateral area will be rectangles. Okay? Bases can change. Okay, but the lateral area always made of rectangles. Now, in a pyramid, if we pop down here, our pyramids, once again, the bases can change shape, but the lateral area is consistently triangles. Before it was rectangles, now it's triangles. Cool. So a triangular pyramid is a triangle base. You can see the part that's shaded down here. A rectangular pyramid, or it could be a square pyramid, rectangular square base, pentagonal pyramid, hexagonal pyramid, so on and so forth. They all come to a point, they're all made of triangles. Now, to get our total surface area, we're going to add all of our sides. So, really, in this unit, we're going to, or in this particular section, we'll be finding area of triangles, rectangles, and other regular polygons to help get our total surface area. Some parts that we're going to refer to here with pyramids, or maybe a little new vocab. One thing is called our slant height. Oops. And it's perpendicular to the base, an edge of the base. Okay, cool. Now, let's see here. What else? We got our height of the pyramid goes from the vertex of that pyramid, that peak, down to the center of the base. Okay, so there's height and there's slant height that we'll be referring to when we're talking about pyramids. All righty, starting off with a bang here, we've got ourselves a hexagonal prism. How do I know it's a hexagonal prism? Well, my bases, remember there's one we cannot see, are hexagons. And they are parallel to each other, right? They'll never touch. Okay. So that's how I know it's a hexagonal prism. So we want to find the lateral area, which will be adding all the rectangles, and then the total surface area, which we'll just add in the bases. Okay. So total surface area, lateral area plus bases. Cool. All right, well, let's go for it. Let's find our lateral area first. So I'm going to do that in blue. Lateral area is going to be equal to, well, there's a bunch of rectangles, right? And they're all 4 by 5, if you can read that. It's a little blurry. So a bunch of rectangles. How many do I have? I have 6 rectangles, and I'm going to multiply that by the area of each one, which would be 4 times 5. So that's 6 rectangles times 20. So I'm going to get 120 units squared for my lateral area. Okay, that's a start. Wonderful. Fantastic. I like it. Now onto our bases. Well, our bases are kind of a whole nother beast here. Okay. So let's see what we can do here. It's a regular hexagon. So I'm going to draw that up. I'll do this one in red. Not bad. Um, so I got my center here, and then I'm going to draw a triangle in. If we remember back to chapter 11, 11.5 specifically, finding the area of regular polygons. This can involve trig. But with a hexagon, this central angle here is 60 degrees. And what do I need for my area of a regular hexagon? It's 1/2 times the apothem times the perimeter. Well, I've got my sides are all 4, so my perimeter is not going to be too bad. It's going to be 6 times 4, which equals 24. So that's good. But my apothem's a whole other thing. Well, if I drop my apothem in, that's an altitude of this little triangle here, and it actually bisects that 60-degree angle, and I end up with this 30, 60, 90 triangle. Now, for those of you who are like, dude, I don't remember my 30, 60, 90 triangle. I don't even remember what I had for breakfast. Let's refresh. My 30, 60, 90 is a 1 across from the 30, a root 3 across from the 60, and this is a 2. Often we also put in an X with those. Okay. So we'd have 1X. We'd have X root 3. Let me try and draw that's a little better. And we'd have 2X. All right. I just like putting the X in front of a radical rather than after it. Just looks a little better to me. Okay. So my triangle that I'm dealing with, well, half of 4 would be 2. When I drop in an altitude on what I know is at least an isosceles triangle, because these two are going to be the same. They're radii of a circle if this thing were inscribed and if we actually drew it, because it can be inscribed in it. So I know these are going to be congruent. So it's isosceles at least, and an altitude would bisect this side, making it a 2, right? That's across my 30. The side that I do want is my root 3 side. So this becomes 2 root 3. And now I've got my apothem 2 root 3. So let's pop that into my formula. I see a nice cancellation here. 2.5. Boom, gone. I'm left with 24 root 3. That's for the area of my regular hexagon. How many are there? There's 2. So that becomes 48 root 3. So bases. And since I'm out of room, I'm coming over here to my total surface area. Says it's lateral plus bases. So 120 plus 48 root 3 units squared. And I could just leave it like that if it were to ask me for a decimal approximation, which if we're doing an online quiz, it'll look like that. Oftentimes on paper pencil, we'll keep it exact, meaning what we see here, 120 plus 48 root 3. But if we were to go with a decimal approximation, plug it into that TI-84, I'm always strapped. I'm sure you are as well. I'm going to get 203.138, so on and so forth. So if I'm doing nearest 10th, it's going to be 203.1 units squared. If it was nearest 100th, it'd be 0.14 because that 8 would round the 3 up. So there we have it. Our first problem done. I would say these ones that are involving regular polygons are the most labor intensive. Definitely a pain in the butt because you got to do this whole thing with that, finding your apothem and your, oh my goodness. Oh, it's so much fun, right? Yeah. All right. So we've got ourselves another example here. This time it's a square pyramid. We should have really had right angles marked there, but we are talking about a square pyramid here. It's 18 by 18 and it has a height of 12, not a slant height of 12, but a height of 12. But we often look for little triangles, right triangles within these solids. Alrighty, so we've got three parts. Find each lateral face. All right, remember our lateral faces are going to be triangles with a pyramid. Find the pyramid's lateral area, so add those all up. And then the total area, add the base in. Okay, so lateral face is going to be a triangle. Well, let's see here if we can figure out what's going on. I've got 12 for my height. Um, if I'm going to get the area of the triangle, I'm going to need that one right there because that's what's perpendicular to this base here, right? So if I'm isolating this triangle, I know that this is 18 meters, but I don't know what my height of that triangle is. Let's figure that out. Well, this right here is going to be halfway across the square, so that's 9 meters. This is a 9, 12. Ooh, 15. If you remember your triples, that's a 3, 4, 5 that's been tripled, a triple, triple. Woo! All right. So I've got 18 and then a height of 15. Awesome. So area is equal to 1/2 my base, which is 18, times my height, which is 15. Ooh, oh, little voice crack there. That was pretty cool. I'm gonna leave it in. All right, so I get an area of 135 for that triangle. So that's 35 for one lateral face, meters squared. All right, so the total lateral area, I'm just gonna multiply that by how many triangles there are. So 4 times 135 is equal to 540, if I'm not mistaken. Well, I'm gonna double check. Yep, 540. Okay. Whew. So now I got to get the total area. Well, if I have the 540, that's the lateral area. I need the base area. Okay. So base area. Well, that's going to be 18 times 18, right? It's just a square, which is 324. So 324 meters squared. So my total surface area, add those two up, it's going to be 864 meters squared. All right. There's the final answer. But we did have to use a little bit of Pythagorean theorem or Pythagorean triples if you remembered them when figuring out some of those missing dimensions. Because our height of the pyramid, the 12, isn't really something that plays into surface area. It will play into volume, though, later on. All right, our last example here, we got to find the surface area of this box if the top is open. We have open top box. So really, we only have a five-sided figure when you really think about the surface area of this thing. So let's think about like what sides are the same. Well, if I found this side here, which one matches up? Well, it would be this one over here. So sometimes I find the easiest way to find our surface area is just to add all sides, right? I mean, we're dealing with rectangles, squares, triangles, eventually circles. Sometimes it's just easier just to add your sides up. All right, so let's do that. Well, these red ones we've got is there's 6 times 7 for the rectangular side, but there's two of them, right? So I'm going to pop a 2 there. So it's 42, 2 times 42, which is going to be 84. All right. That's inches squared. Now I'll change markers here. Let's go with blue. How about this one here? Well, it's 5 by 6. I got that from this guy right over here. All right, so there's two of those as well. Its counterpart is back here. And remember, these guys are parallel to each other, right? These two blue ones are parallel to each other. The two red ones are parallel. Not just lines are parallel. We could have planes as well. We didn't cover that, but basically, like we're talking about rectangles, squares, right? They if they were extended on forever, they'd never intersect. So this is 6 times 5. We get Getting ahead of myself. 2 times 30, which equals 60 inches squared. And then lastly, we'll do green. This bottom one here. Well, that one, its counterpart is the open top. So we're only going to have one of those, which is 7 times 5, which is 35 inches squared. Now, if we're to add all these up, I'm going to be careful because I don't want to make a mistake in a video because it's recorded forever. And it's the worst. This total, after I add them all up, will be 179 inches squared. Not too bad on that one. I really think the first example was definitely the most time consuming and difficult out of all of these. As a quick recap here, guys, let's talk about our two solids that we worked with. We had prisms and we had pyramids. Okay. So here we have two bases, two parallel bases, and here we have one base. But in both of them, the base shape can vary. Sames. Maybe I'll just write it out. Base shape can vary. So it could be any kind of polygon. Any polygon. And remember, a polygon is just a sided figure. It could be a triangle, a quadrilateral, like a square or a rectangle, or rhombus. It could be a pentagon, so on and so forth. Our lateral area is made of rectangles. But over here, lateral area is made of triangles. Okay. Add all sides to get total surface area. Okay, that's the big thing here. Anytime you're a little lost, if I don't ask specifically for lateral area or whatever, if you just ask for total surface area, you're adding all the sides. However you get there is up to you, but we'll go through strategies on how to do that. All right, hope you guys enjoyed this wonderful first video for Chapter 12. You guys have a great day. America, freedom, rock and roll, Costco memberships, and yeah, I think that's about it. Riverdog Jenny on the gram. All right, later.